Alright, so you want to colonize Mars, right? Well, it's not an easy task. Mars is the fourth most distant planet from the Sun and the seventh largest in the solar system. This lonely red guy is very similar to our Earth. Moreover, before it became a boundless desert, it could well have even looked like Earth now. Millions of years ago, there was water, oceans, plants, and who knows, maybe even life. It would be nice to put all these cool things back there. No wonder we've been talking about colonization of this planet for a very long time. Now, SpaceX claims that their proposed interplanetary spacecraft could deliver 100 people to Mars. The owner of the company, billionaire Elon Musk, talked about creating a fleet that could provide a constant flow of resources to Mars. But how realistic are all these fantasies? Actually, not very much. Before sending people to Mars, we need to solve a number of issues. For example, the incredible radiation exposure, toxic soil, low gravity, low temperatures, and all sorts of other nasty things. And this is just the beginning. It will take at least a couple of decades to create a vehicle that can actually successfully land on Mars and return back. But let's do a thought experiment and imagine that we finally decided to colonize Mars. How will things turn out? Recently, scientists published a new study on this topic. This study is called Minimum Number of Settlers for Survival on Another Planet. The author is Jean-Marc Salotti, professor at the National Polytechnic Institute of Bordeaux in France. His article was published in the Scientific Reports journal. As you might have guessed, the study was trying to find out how we could colonize another planet. How many resources do we need? How should this colony live? What kind of work should they do? And how long will it take? And, of course, exactly how many people do we need for all of this? Let's try to answer that. Now, imagine that we've moved into a wonderful future. Well, not really. A terrible future, actually. In his study, Salotti suggested that life on Earth was threatened by some catastrophic event, so the only way for humanity to survive is to go to Mars or some other planet. In this imaginary scenario, unfortunately, the supply delivery from Earth was interrupted, or even gone. Now, the colony has to support itself somehow. Well, here's where we already stumble upon a bunch of problems. For example, we're not sure how well the people in the colony will work together.
Hey!
Will they communicate with each other like normal human beings? Will they share their time and resources as they should? Humans are constantly ruining things for other humans. I can even bet that it was their fault we had to flee to Mars. But even if we forget about that, how about organizational issues? What equipment do we have? What will we use to extract resources? What skills would we need? You know what? Who cares? In our case, these things don't matter. All that we know is that the colony doesn't have a lot of initial resources and equipment, and the human factor is absolutely unpredictable. So the chances of survival are pretty low, but we need to survive somehow. In this case, Salotti describes two things that will have a huge impact on our survival. These things are essentially variables in a mathematical equation. The first one is the availability of local resources. Basically, it means water, oxygen, and all sorts of useful chemical elements. These resources should be somehow mined and easy to use. Fortunately, we're not starting from scratch. We already know a lot about Mars. What resources are there? How can they be used for life support, agriculture, and industrial production? The colony is lucky because all this has been studied at various seminars and published in reports and books over the past years. Thanks to this, we know what will be available to our colony. For example, we know that gases could be extracted from the atmosphere and minerals from the soil. On Mars, we could provide such things as iron, glass, and even organic compounds. The most important problem here is the service life of the equipment that our new Martians start with. They'll have to get as many materials as possible before the tools break. Keeping them in good condition will be almost the most important task. The second thing is the production capacity, or the speed of work. We have a specific list of things we need to do, make some tools for example, and all this must be produced in sufficient quantities before the literal deadlines. Salati says that the most important thing here will be the so-called sharing factor. Imagine one person trying to survive on Mars. They would have to do all the tasks on their own. They would need to find or build their own system for supplying drinking water, oxygen, and electricity generation. We've already seen how this played out in the movie The Martian. This task wasn't easy at all. There's always not enough time, and all of this is just too much for one person to handle. Unless you're Matt Damon, of course. So, surprisingly, we need a fairly large colony. This significantly distributes the burden. Each person spends less effort, gets tired less, and, as a result, the efficiency and speed of work grow. This is where the sharing factor comes into play. Now we need to calculate this number. If we want, for example, to build something, how many people do we need to do this quickly and efficiently? How can we optimize the work as much as possible? Well, it depends on the needs of these people, on available resources, random things like weather, and so on. But in general, this number can be estimated and calculated using some mathematical functions. Salati tells in more detail about these functions in his article. You can read it yourself if you're interested, but in general, he describes 5 areas that need to be taken into account when calculating this number. These areas are ecosystem management, energy production, industry, buildings, and the human factor. The human factor includes such things as the upbringing and education of children, sports, games, music, and so on. In the end, it all comes down to 2 things: how much time we have and how well the people in the colony will work with each other. So, what was the result of all these calculations? In the end, Salati found out that we would need at least 110 people to successfully survive on Mars. This is the minimal number needed to create a self-sufficient civilization. And it will be better if we don't take too many people with us. The more people we take on the spacecraft, the more difficult it will be to predict the results. After all, as we've already said, humans are always ruining things for other humans. So it's better to stick with about 110 people. Of course, this is a rough estimate, and there are a bunch of different assumptions and uncertainties, but even this number is already very useful. Now the scientists know how many people is a minimum for colonization of another planet. Colonizing other planets is a very complex issue, and it will take us a very long time to resolve it. It's very unlikely that we'll fly to Mars in the near future. This task may take several decades, or even a century. Therefore, the best solution would be to try our best to save Earth until we can begin to conquer other planets.
It's staring at you, and you're staring at it. A giant eye that seems to be pulling you into an abyss. You're hovering over it in your spacecopter. But however scared you might be, you still need to do your job. So you send your copter down to the surface of the red planet. Right, that's where you are, on Mars. But first things first, you take a moment to remember everything you know about the 4th planet from the Sun. It's the last of the inner planets. Those are the planets that lie within the asteroid belt. They're also called terrestrial, since they're made up of rocks and metals. The atmosphere of Mars is much thinner than Earth's. It contains 95% carbon dioxide and a mere 1% of oxygen. In other words, don't even think about pulling off your helmet. Anyway, there's no time to waste. You land on the surface of the planet and find yourself in a brownish-red world. That's a good thing you're wearing a spacesuit. This place is freezing cold. The thermometer sewn into the sleeve of your suit shows minus 80 degrees Fahrenheit. Time to take your first step on the Martian surface. The planet looks quite colorful, and the hue of a particular area depends on the minerals that make up the soil. The ground under your feet is covered in fine dust. It looks like rust. The same orange dust is in the air. Good thing you have your own supply of oxygen and don't need to breathe Martian air. The layer of this dust covering the surface of Mars can be from 6 to 40 feet thick. You hope you'll avoid getting swallowed by some Martian quicksand. You start walking, feeling very light. Mars is just 15% of our planet's volume and a mere 11% of Earth's mass. It means that gravity here is much weaker. Its pull is 38% as strong as the pull of gravity on the surface of Earth. You jump up and down and then try to run several hundred feet. Ha! You haven't even broken a sweat. What makes it harder for you to explore the place on foot is that the planet's surface is rocky, covered with craters and volcanoes, old dry lake beds, and canyons. You see something huge towering on the horizon, but you try to suppress your curiosity. You'll have enough time to figure out what it is later. Suddenly, a massive cloud appears in the distance. It looks as if a huge herd of horses is approaching you. In reality, you better get back into your copter and fly away as fast as you can. That's one of Mars's infamous dust storms. They mostly occur during the summer in the southern hemisphere of the red planet. They can sometimes cover the entire planet, and you see the largest ones from Earth. You hop into your copter and set a course for the eye that scared you so much. Winding channels that look like veins run through the eyeball. But the closer you get, the less it looks like an actual eye. Soon you realize it's a crater. It's giant, almost 19 miles across. Around the crater, which looks as if it has a pupil, there are other even bigger craters. They likely formed billions of years ago. That's when Mars had to withstand multiple attacks of space rocks. But why is the eye crater darker than the surrounding landscape? Scientists think that once there was Martian water in the enormous pit. Remember those channels? They were likely carrying that water. And since the crater was filled with water, it stopped some substances and minerals from eroding away. Now, remember that towering something on the horizon? It's time to go and explore it. When you come close, you realize it's the largest shield volcano in the entire solar system, Olympus Mons. It's more than 370 miles in diameter, which is almost the same size as the state of Arizona. You tilt your head. Wow! The mountain is 16 miles high. It's also rimmed by 4-mile-high cliffs. To picture the sheer size of the volcano, let's make some comparisons. The largest volcano on Earth is Mauna Loa, towering around 2.5 miles above sea level and stretching 75 miles across. Sounds impressive. But the volume of Olympus Mons is around 100 times larger than that of Mauna Loa. The Martian giant could swallow the whole chain of Hawaiian Islands from Kauai to Hawaii. But why is this volcano so large? It might be the result of lower surface gravity and higher eruption rates. Or the reason might be the red planet's crust, which is very different from Earth's. It's static. You see, on our planet, the crust is made of 15 to 20 moving tectonic plates. As plates move over hotspots producing lava, new volcanoes form, and the already existing ones become extinct. That's why lava can get to the surface through many vents. But on Mars, the crust isn't broken into the same tectonic plates as on Earth, and the lava has nothing to do but pile in one very, very large volcano. So, how about getting closer to the enormous mountain? But once you step out of your copter on Martian soil, the ground under your feet starts shaking. Well, that's a Marsquake. But how can it happen if Mars doesn't have any actively shifting tectonic plates? Specialists from NASA are sure Marsquakes occur when energy inside the planet gets suddenly released. It leads to rock fractures and cracks in the planet's crust. Another powerful jolt, and one of such cracks opens right next to you. You fall to the ground, afraid to move, but soon everything calms down. You wait for a couple of minutes, just to be sure, and get up. Oh look! Here's a perfect opportunity to explore the insides of the red planet. The crack is large enough to send a special research robot. The planet's crust is thin and consists of volcanic basalt rock. The mantle that surrounds the core of the planet is made up of thick silicates, oxygen, and some minerals. You can probably compare it with soft, rocky toothpaste. Mars's mantle is also much thinner than Earth's. It's just 800 to 1100 miles thick. As for the planet's core, it's made mostly of iron, nickel, and sulfur and is between 900 and 1200 miles wide. This core doesn't move. That's why Mars doesn't have a planet-wide magnetic field. Unfortunately, your drone is now lost in the depths of the red planet. You leave it there and continue your exploration. Your next destination is Valles Marineris. It sounds more like an Italian red sauce, but it's actually an enormous canyon, or rather a canyon system, that runs along Mars's equator. It's as awe-inspiring as Olympus Mons, more than 2,600 miles long and over 4 miles deep. The thing is so huge, it could span the entire continental United States from the Pacific to the Atlantic Ocean. Now let's make another comparison. One of the most famous canyons on Earth is the Grand Canyon in Arizona. But it's 10 times shorter and around 4 times less deep than this canyon on Mars. Some scientists think that Valles Marineris is the edge of an enormous tectonic plate. It moves so slowly that almost nothing has happened in that region over millions of years. And the movement of this plate probably began 3.5 billion years ago. Anyway, the only thing left on your today's to-do list is to visit Mars's moons. They're among the tiniest in the solar system. Phobos is the largest of the two. It orbits a mere 3,700 miles above the surface of Mars. There's no other known moon that travels closer to its mother planet. It whips around the red planet 3 times a day, while the second moon, Deimos, needs 30 hours to complete one orbit. Phobos is getting closer and closer to Mars, about 6 feet each 100 years. Within the next 50 million years, it'll either crash into the planet or break apart and form a ring. Happy but tired, you return to your spaceship. Tomorrow, you'll continue exploring the magnificent red planet, and who knows what discoveries are awaiting you.
Hello there. Thank you for coming to the Space Job Agency. We have a whole bunch of departments. Intergalactic jobs, keep it in Milky Way, our solar system rocks, or gases, and many smaller ones. Tired of a 9-to-5 routine on our planet? No problem. Let's see if you have any qualifications for newly open positions. So, we've got here... Oh! An asteroid miner on Mars. As you know, asteroids are some sort of leftovers from times when our solar system was forming. Our scientists believe it's debris left of planet collisions and destruction. Tens of thousands of asteroids are circling our Sun, and most of them are between the orbits of Jupiter and Mars. That way, Mars is a perfect location for this job. Those asteroids can hide a lot inside. They're made of magnesium, iron, nickel. We believe some of them consist of oxygen, gold, water, and platinum. We need those for our industries. We have a station with food and everything else you'll need up there. So, you're in a specially designed spacecraft. You start from Mars, land on an asteroid, and start mining. Our machinery is lightweight and solar-powered, which means you need less fuel. Sometimes we send robots to do this, sometimes people. Robots don't need food or other supplies. On the other hand, they're not so precise as humans. You use similar techniques as miners on the Earth. Basically, you'll need to scrape the material off the asteroid. The majority of the ore will probably fly off, so you'll have to use a big canopy to collect it. Since the gravity on asteroids is so much weaker than on Earth, you'll have to learn how to use grapples to anchor yourself to the surface. That way, you can move around with little effort. Once you're done with one asteroid and the material is sent to Earth, you're going to the next one. Are you good at sports? I can see there is an ad for a ski instructor on Mars. Mars has 4 seasons, just like Earth. And winter there lasts around 6 Earth months because the year there is almost twice as long. The snow there is different because it's made of frozen carbon dioxide instead of frozen water. But don't worry, the best scientists made it completely safe. Snowball fights are not so fun. You get a poor pack of frozen carbon dioxide and a bit of water ice. But snowboarding, sledding, and skiing there are so cool. No, literally, the surface is almost frozen. The snow is not as thick as on our planet, but the surface is very slippery, so it's fun. So, you're gonna work there for 6 months, but if you plan to make some extra cash, we're transferring you to Europa, one of Jupiter's moons. Europa is very cold. Its surface is mostly composed of solid water ice, a subsurface ocean we didn't get to see yet. But, hey, our team of space divers is going there in 3 months. I'll check if there's a position open if you're interested. They say this ocean might have twice as much water as we have on Earth. Plus, our team of scientists still think this is one of the best spots to build Earth-like cities in our solar system. But until then, you can go as a skiing instructor. The surface is made of ice, so we created our own snow to go skiing. You'll like it there. There are many hills and domes on Europa. Some ridges are 5.5 miles across. So if you want some adrenaline, Europa has little to no atmosphere, so your suit protects you from radiation from the sun. Okay, the next one is a driver in a space taxi on Venus. Tourists love going there, despite that it's very, very hot. It's further away from our sun than Mercury, but it's still hotter. The thing is, the atmosphere there is like a blanket that traps the heat. The planet is scorching, so you can't stay there for too long. The company will provide you with a flying car that looks like a mini spaceship. You'll have to be a pretty good driver because the atmosphere is very dense. And it's also quite windy there. The speed often goes over 220 miles per hour. And it can get tricky with the clouds. You won't be able to see because the wind's moving them all the time, so you have to act fast. Plus, Venus is the planet with the most volcanoes in our solar system. Much of its surface is covered with volcanic deposits, making it hard to land and find a safe spot to land. If you accept this job, here's a tip. It's better to stay in the air. The view is amazing. Speaking of volcanoes, you can probably join our team of space volcanologists. As an assistant first, of course, but later, we'll see if you can take a better position in an intergalactic team. For now, you can stay in our solar system. We presume Mars, Venus, Pluto, and Jupiter's moon Europa have active volcanoes, but there's still no proof of that. The spots we know about for sure are moons Io, Triton, and Enceladus. Moon Finder. We have a department that's looking for new moons, even outside our galaxy. There's also another one where you get to visit and explore moons in our solar system. It has more than 200 moons, so you certainly won't get bored. If we're talking about a planet where you can't even land, like gas giants Neptune, Uranus, Saturn, and Jupiter, you'll visit their moons directly. All major planets have moons, except for Mercury and Venus. You'll have to visit these planets first and try to find their moon. Moons are awesome. For example, Dactyl is a moon that doesn't orbit a planet, but an asteroid. Before this, we didn't even know asteroids could have their moons. Hyperion orbits Saturn. It has an irregular shape, and we believe it's probably a part of a much bigger, ancient moon that got destroyed from a collision in the early stage of our solar system. It has a low level of density, almost half that of water. And what about Callisto, the oldest one? It orbits Jupiter, and its craters are 4 billion years old. Callisto helped us understand so much about our solar system. Space Jeweler. If you want to leave our solar system, you can visit what we call Diamond Planet. It's 41 light-years away from Earth, located in the Cancer constellation. It's twice as big and dense as Earth, but almost 8 times more massive. Its parent star contains way more carbon than our Sun, and this planet probably contains carbon too. The pressure and the temperature are huge, but we have a unique technology to deal with that. It's covered with diamonds, so your job is to collect it and make some amazing space jewelry. You can visit more interesting planets as a space jeweler, like one where it rains rubies and sapphires. The storms there are pretty crazy, but you only get to collect gems scattered across the planet after it's over. If you're more into making something out of glass, there's literally a planet where it rains glass. It's located 63 light-years away from us. It's a little bigger than Jupiter, and you'll be amazed by the planet's atmosphere. It has a stunning azure color because it's mostly made of silicate. The wind there is crazy. It hits 5,400 miles per hour. For comparison, the fastest one we've experienced on Earth was 254 miles per hour. Oh, and the last one, Explorer, on the mission called Planet 9. Beyond Neptune, you'll see many small worlds peacefully dancing in harmony, and the stubborn one that's still hiding, the Planet 9. We've been looking at it for a very long time. Our scientists think it exists because they noticed gravitational force affecting a small group of objects with clustered orbits. Planet 9 probably orbits our Sun in 7,400 years. It's 6 times as massive as Earth. It's either a gas giant or some sort of mini Neptune, or even a rocky super-Earth. It's well paid, but I must warn you, it's a mission of your lifetime. We don't know when you'll be able to go back. It's far away. Neptune is the starting point of our investigation. It's a gas world, so you can't land on it. So you'll have to go to one of its moons called Triton. It's made of nitrogen ice and rock. You'll be fine. Just watch out for geysers there. They erupt on the crust, and then the atmosphere blows them away, and we're still not sure how dangerous they are. And you'll have to wear a special suit because that's the coldest space object in our solar system we know about. So, are you accepting any of the offers?